By the end of summer, a sunflower had grown tall beside the pond. Its face was full of seeds, more than a puppy could count, and it turned all day to follow the light. Baloo pressed his nose to the sunflower's face. "Frog, the seeds go in curves. Curves this way and curves that way, both at once, and I don't think it's an accident." "Watch," said Baloo, and he placed the seeds one at a time, each a small turn from the last, the turn always the same size, and a spiral began to open on the stone all on its own. "You did not draw the spiral." "No, I only made one turn, again and again. The spiral drew itself. That is the number that draws." Baloo gave Frog a pine cone. "Two families of curves again. Count them one way, then the other, and you get two numbers. And the second is made of the first. Each new number is the two before it added together." On the still pond, the cardinal's flight traced a widening spiral, the same curl as the shell, and the seed, and the far turning of the star.
So, you want to know the number the flower knew before you did. A growing plant lays down its seeds one at a time, each turned a fixed angle from the last. Ask which angle packs the most seeds with no gaps, and everything hinges on one number. Turn by a simple fraction of a circle, a half, a third, 2/5, and the seeds quickly line up in a few straight spokes, leaving whole wedges of the flower empty. To never repeat, the turn must be an angle no simple fraction can ever quite match. That angle comes from phi, about 1.618, the golden ratio. And phi has a real claim to being the most irrational number there is, the hardest of all numbers to approximate with a simple fraction. Turn by the slice phi carves out, and you get the golden angle, 137.5 degrees. The one turn that never brings a new seed into line with an old one. So nothing is wasted. As Baloo said, it isn't magic, it's only not wasting room. Now, count the spirals, one way, then the other. You will nearly always get two neighbors from the Fibonacci sequence. 1, 1, 2, 3, 5, 8, 13, each number the sum of the two before it. This is not a second coincidence. The fractions built from Fibonacci numbers are the closest simple approximations to phi. So those are the directions the seeds come nearest to lining up, and your eye catches them as spirals. The same number seen twice. And it is real. In 1992, Doherty and Cowder grew the very same pattern from magnetized droplets. No life, no genes, showing the golden angle is simply what efficient growth does. Here then is the wonder left standing. A number, a bloodless abstract thing that lives in no place and weighs nothing, is written into a flower you can hold in your hand. The seed does not know what phi is, it simply grows, and phi is already waiting for it.